common virus strongly linked to multiple sclerosis onset, mounting evidence points to the Epstein-Barr virus, EBV. One of the most widespread viruses globally, as a key trigger for multiple sclerosis, MS, a debilitating autoimmune disease. For decades, scientists have suspected a connection, but new research is now revealing how the virus may be driving the disease's development. The ubiquitous EBV and its mysterious role EBV, responsible for infectious mononucleosis, kissing disease, infects approximately 95% of the adult population. It persists in the body, sometimes even hiding within brain cells, long after initial exposure. The striking correlation between EBV infection and MS has been known for some time. Individuals with MS almost universally test positive for prior EBV exposure. A landmark 2022 study of over 10 million people revealed that MS risk increases 32-fold after EBV infection, a link far stronger than any other virus tested. Killer T cells, as the missing piece researchers at the University of California, San Francisco, UCSF, have now identified a plausible mechanism behind this connection. Their recent work shows that killer T cells, immune cells designed to destroy infected cells, are significantly more abundant in MS patients. Critically, many of these T cells are specifically activated against EBV proteins. Looking at these understudied CD8 plus T cells connects a lot of different dots and gives us a new window on how EBV is likely contributing to this disease, says neurologist Joe Sabatino at UCSF. This suggests the immune system mistakenly attacks the body's own nerve fibers after being primed by the virus. Evidence from blood and spinal fluid, the UCSF team analyzed blood and cerebrospinal fluid, CSF, from 13 MS patients and compared them to 5 controls, including those with other inflammatory conditions. The results were striking. EBV-reactive killer T cells were up to 100 times more concentrated in the CSF of MS patients than in their blood. This indicates an aggressive immune response occurring within the brain and spinal cord. Furthermore, active EBV genes were detected in the CSF of MS patients' genes that were absent or inactive in those without the disease. One gene, in particular, was exclusively active in MS patients, suggesting the virus is not merely present, but reactivating within the central nervous system. Wider implications for immune-mediated diseases, the implications extend beyond MS. EBV is increasingly linked to other autoimmune and neurological conditions, including lupus, certain cancers, schizophrenia, long COVID, chronic fatigue syndrome, and even dementia. Understanding how EBV manipulates the immune system could unlock treatments for a wide range of illnesses. The big hope here is that if we can interfere with EBV, we can have a big effect, not just on MS, but on other disorders, and improve the quality of life for many, many people, says Sabatino. Interfering with EBV could lead to major breakthroughs in treating numerous diseases, not just MS. The virus's role in immune dysfunction is becoming clearer, and future therapies may focus on controlling or suppressing EBV activity to prevent or alleviate these conditions.